Recording up. Okay, so we are gonna continue talking about GitHub Actions workflows. We're gonna continue looking at how to write these workflows, starting with some of what we started looking at yesterday, which was adding components to the workflow to set up a full stack application. Essentially, it's the same steps you've done in the previous assessments. On top of using Terraform and Ansible, we've thrown GitHub Actions into the mix. We're also going to try to get Elasticsearch and Kibana and Logstash up and running through GitHub Actions. So let me share. Have you all covered Elasticsearch at all yet?
I don't think so.
I don't think so.
No, we didn't. Okay. All right. It makes sense to go over it this week because this week's theme is monitoring and alerting. And basically, we're going to show you a range of tools that you could utilize in the pipeline that you will be building next week. So yesterday we talked about CloudWatch and service level management. Today we're going to go through some other tools. And let's start by just talking about what the Elastic Stack is. It's basically a lightweight stack utilizing Elasticsearch and Kibana, which is a dashboarding tool, and Logstash. Oh no, I think I might have closed the window. No, there it is. A way of holding your data so that it is accessible inside of Kibana. We're not gonna go too deep into this. I am hoping that we can get some kind of view up. If we go to today's README, what we have right now is the manual installation for Elasticsearch. We'll be hopping onto an EC2, running some commands to install Elasticsearch, and then testing it using a curl command. But before we do that, let's go ahead and just run through some additional details for what these are. Okay, so we talked about the Elastic Stack, formerly known as Elk Stack, as being a set of open source tools designed to help users collect, store, search, and visualize data. It is basically, it works off of the Elasticsearch, which is a RESTful search engine. And so the way that we integrate it into our application really works nicely with what we've been showing so far, right? So we want separate Docker files to containerize different parts of our full stack application, that being our Postgres database, our Flask API, or Django API, whichever you prefer, and our front end, which can be a very simple HTML, CSS, and JavaScript application, or you can use a more robust framework like React. So similar to that, we'll be eventually using Docker Compose, but for now, using multiple Docker files to set up containers for each of these open source tools. Elasticsearch itself is designed to be fast and scalable. Logstash is used to parse the logs and the metrics and store them in Elasticsearch so that they are available for Kibana to visualize and for us to search through with Elasticsearch. So I think this is what we just looked at, or close enough. It's the documentation from the same website. Let's see. If some of you might be already familiar with different enterprise tools, like is anybody here familiar with Splunk, for example?
No.
I've heard of it.
Okay. This this view looks very similar to Splunk, right? It's like essentially the exact same layout. You've got a search bar at the top, um, a graph visualizing the results, and an ordered list of the results that have been retrieved. And learning one tool should give you enough familiarity that you can figure out how to learn other similar tools. Wherever you land after your job search, you'll be using whatever tech stack the organization is using. And so there's no guarantee that you'll be using Elastic, Kibana, or Logstash. You might be using Splunk and Datadog and Grafana instead, or something along those lines, some combination of these different tools. So the reason we write the lesson, well, I guess one of the reasons that we wrote a lesson around these is because they are open source. So that makes these more accessible um, off the bat. And we, I mean, these are just essentially these pros for each of these tools. They're true, but they also are kind of very general, right? So they kind of also apply to very similar tools. Splunk has the ability for us to scale up or down, um, to search for data in real time. So really, when you're working with these tools, it's kind of good to think about these pros, these qualities as as a general rule of thumb, applying not only to the tool that you're using, but the type of tool that it is, right? Basically, you could infer that um, the best search tools out there will at least have these kind of selling points. Same with our data visualization tools like Grafana and Kibana, and same with metrics collectors like Beats or Datadog. Okay, so when we talk about compatibility, or let's talk about comparison first, compatibility with AWS afterwards. Comparing this to what we have so far, what we've used so far in CloudWatch, there's a lot of similarity, right? Like they both support log collection, log aggregation, monitoring, alerting, and dashboarding. CloudWatch does not support custom plugins, but one could argue that you don't necessarily need custom plugins for CloudWatch because you have access to all sorts of other AWS resources. So if you needed some more complex behavior that doesn't arrive in the box with whatever tool you're using, you can get creative and use a combination of their other tools like Lambdas and S3 buckets. Pricing. Pricing is probably going to be cheaper with open source tools. Um, because you could use them freely, or you could also work with whatever services are provided by each provider. And it's generally going to be cheaper than major organization like AWS. But again, that's kind of beyond your purview, right? Because unless you're going to be joining a startup off the bat, and even if you do join a startup, but more on that later, you probably won't have to worry about deciding what tools do I use for my tech stack, right? So with all that said, let's jump back to this Elasticsearch. Let's see if we can, well, let's see first what the status is on our EC2. Okay, so actions. I'm just gonna go ahead and rerun this. If we look at the error, oh no, this is a different error. Oh wait, no, this is the error that I did see right before class. Um, the EC2 became unreachable. I think I just basically killed it. I was doing too much on it. So let's try rerunning, see if it continues to give us trouble. And if it does, then we'll just manually set up another EC2 and run through this that way. So, okay. While we are waiting on this to do its thing, let's go ahead. Let's go to AWS. Let's set up a new EC2. Call it demo. We do want Amazon Linux. Actually, let's go with Ubuntu. I think the install commands written in the lesson are for Ubuntu. So we'll choose our free tier micro instance. We'll use the class key pair, or one of the many class key pairs. There we go. And we'll use the default VPC settings. Let's see if there's an existing security group that we can just use off the bat. And I'm using this one, by the way, whatever I selected, because it's the one that I've been configuring inside of my project here. So if we look at our files in this project, and specifically our Terraform, we'll see that a security group is already set up to expose ports for all of our applications requirements. We've got 22 for SSH, 80 for HTTP connections. We're exposing port 5000 for our Flask API, 5050 for PG admin, which isn't an absolutely critical tool. But if you wanted to more easily manipulate data inside of your database, tools like PG admin can do that for you, especially if you prefer UIs over command line and SQL and all of that. Let's see. This also looks like I'm on the wrong branch because there should be more to that. So let's go back to the right branch. And we've exposed some additional ports. Right here it is. So there's where we left off. We also exposed 9200 for Elasticsearch and 5601 for Kibana. So this should be what we need. I'm also curious to see what happens here. Same thing, timed out, unreachable. So let's go ahead. Oh, I don't need to change any of this. All of this should be good. Making sure that my public IP is enabled, or the auto assigning of the public IP is enabled, I should say. And I think we're good to go. So let's launch that. Let's wait for that to set up. While that is setting up, we'll go back here. We'll talk about something that we haven't uh, looked at too closely, but that we did briefly mention yesterday, right? When Jeremy raised the question about, well, how do you destroy resources? So, um, if we want a workflow that in this case will just destroy our EC2, because I think the EC2, we've used up all our allocated bandwidth on it. And instead of waiting for more bandwidth, we could just destroy it and create a new one. We have multiple ways of doing that. One is to remove the EC2 from your Terraform and rerun the apply, and that should destroy it. But what if we wanted to keep the EC2 but just stop it, right? So let's see. Terraform, AWS provider. Let's look at our documentation for our AWS instance, and let's see if we could find any properties for stopping the EC2. This looks, well, that's for spot instances. We don't want that. Okay, there we go. Instance state. I think that's what we want. Or let me just double check. This might be set inside of lifecycle. I'm sure. Okay. Well, let's try it. The worst thing that can happen is it tells us that it doesn't like the configuration and then it fails. So that was what instance state, right? So let's read up on this. AWS does not currently have an EC2 API operation to determine an instance as finishing processing user data. Okay, that's not really important to our current goal. So this will grab the ID of an instance or reference the ID of an instance, and it will also specify the state. So in this example, we've got an instance that we create called test, and we create another resource that I'm assuming puts it in a stopped state. So let's see if this is what we want. Let's go back to our code. Let's clear up some of this noise. And going to our Terraform, not our workflow, but our Terraform. Oops. Let's add a state for our instance. So here we've got the instance defined. Let's go ahead and I'm gonna duplicate this so I can make another one. Make a second one. Gonna look through this. If there's anything I need to change, does not look like it. We're also going to add a state for this EC2, and we'll just call it stop. Actually, this label itself shouldn't matter, but to make it more clear, I'll call it something like stop CP DevOps evening weekend Charlie. Let's see if this works. I could just push this right now. I could also run Terraform apply locally, but I'm trying to think through whether or not I want to do that because I do have state being handled remotely right now. So what would happen if I did try to run this? I have a feeling the plan would fail because running the Terraform by itself means it will be skipping these steps, right? These steps that check to see if these resources have already been created, if a security group exists, which is that it's not equal to none, then we use Terraform state list to grab the values we want, referencing those resources, and then we import. So I could run these manually in my terminal, or I could just push the changes and let GitHub Actions workflow do its magic. I think there shouldn't be any running instances. Okay. So yeah, let's do that. Let's just go ahead and add it. Add instance stopped. That should kick off. And while that's going, this should be all set up and good to go. So let's go ahead and connect to this one. Okay. Go to our SSH directory. Let's SSH to this new EC2. Say yes. Okay. And let's also grab today's lesson. This one should be this one. Okay. Oops. Right. We are first going to run our sudo apt-get update. Followed by an upgrade. Yes. And then we have to run this command. We're basically using wget to grab the artifact from Elastic's servers because this does not exist in any of the AMIs as a package inside of the package managers. So we'll have to manually grab the artifact. We'll then run apt-key to add it. to our package manager. Um, we'll then install it and we'll list out some logs. So let's go ahead and do that. Cool. Looks like that succeeded, no errors. And on another update because it's asking us to. And let's see if this installs. Enable locate package Elasticsearch. Okay. All right. Let's see. This documentation might have already expired because we are now on a version of Ubuntu that might be later than the one that was used when this was written. So let's go over to Elastic. Let's see if their documentation can help us get set up. Okay, so here's the quick start. All of this so far is related to the UI. That's a good search. June 22. This is from 6 months ago. So let's check this one out. Okay, this wants us to install Java. Okay, so it wants us to install these OpenJDK, and it wants us to install Nginx. Okay, here's another repository. Let's see if that's different from the one inside of here. It's not. It looks like the exact same repository. Okay, let's stick with this for now. Let's not worry about the Java portion yet. So we can get rid of this. I don't know why this copied all these extra characters. No OpenPGP data found. Okay. Interesting. All right, let's pause on that. Okay, this failed. Yikes, timed out again. Oh, okay. So let's look at our workflow. Of course, I didn't make enough changes, so it was going to fail because if you remember we basically added a second EC2 and we set a resource to stop that first EC2, but we didn't update the workflow that utilizes the IP address given to us from the EC2. And right now it's still giving us the IP address from the first EC2. So if we look at these outputs, they're all still referencing the original EC2, which should now be in a stopped state. And if we go back to our workflow, what's happening is sets up Terraform. It will write private keys to the workspace using the GitHub action secrets values that we've set. It runs Terraform init. It checks for existing security groups. It runs plan and apply. And then here, we are actually outputting the EC2's IP address. So we use Terraform output command to grab the public IP of our EC2. And we store it as both an environment variable and an output. Do we have to do both of these? No. I included both as examples of how you could do them. But the difference here is this environment variable is only available to this job, okay? So if you tried to access this environment variable in the next job, it will fail. So we use outputs instead to pass data from one job to another. And the setup is a little funky, but basically at the top of our first job, we set a line for our output. We're essentially assigning it to this variable ec2-ip. And the syntax in here is it's grabbing the steps, it's grabbing the set IP step specifically, and let's start minimizing some of these. And it's not the name that it's grabbing, right? It's an ID. So we use the ID line to make it accessible through the syntax. And within this specific step, we grab from the outputs the EC2 underscore IP underscore output. And we set that by using echo to basically create a key value pair where the key is EC2 underscore IP underscore output. And the value is the IP address from Terraform. And we use our, oh, why am I blanking on this? This redirect to output it to basically an output. It's essentially just like a variable, but it will persist outside of the job. So these logs will show that we see the environment variable inside of the step itself, but well, this is incorrect, I think. If we tried this, it's referencing itself, which is why I don't think this line is correct. That's why that's an empty value. Output 2, it's the same thing. I just copy pasted, I think, from one job to another. But we see that the output that's being shown here It's the same IP address that we have defined earlier up here. And so let's go back to a run that actually succeeded so we could see that in effect. Okay, so this was the last working run before we added the elk stack. If we go to the IP address in the first job, when we see something similar, it's set for the output, not the environment variables. And if we look at that same log in our second job, we see that the IP address shows for the second value, but not the first. Okay, so why is that happening? Steps.setIP.outputs showed in the first job because it's essentially able to reference itself with this syntax, right? It can't use needs to reference itself. This job can't use needs to reference its own name. This job can reference itself using steps dot set IP, which again is the ID of the step, dot outputs, dot whatever the name of the output is. So this works in the first job. These don't work in the first job, but this works in the second job. Because if you look at the second job, oh, we're already down at the second job. Yeah, if we look at the second job, we're basically saying we need the first job to complete. And from that first job, we grab its outputs and we grab ec2-ip, which is what we set up here. Okay. Let's go back here. What else? What else? What else? Right. Okay, so we did not change the IP address that we were referencing, right? And that's why that last run failed. We're setting that first instance to stop, and I actually want to double check that. Let's just confirm that's the case. So let's go back to our AWS console. Let's go to our EC2s. Let's see what's running and what's not running. Okay, great. So we have a stopped instance. This should be the IP address that it's been returning in our logs. And we also have an alarm for it, probably from the monitor we set up yesterday. Yes. Aha. So this is why we had not been able to access the EC2. And because we set up our monitor yesterday, we are able to see this inside of CloudWatch. Okay, so back to using the right IP address. We've made a new EC2, right? Charlie_2, but we're still referencing the IP from the first address. So let's go ahead and change that by, this isn't absolutely all necessary, but I'm going to grab these at the very least, and I'm going to duplicate these. I think I'm going to need that last one too. And I'm going to rename this to use B instead of A. And I'm also going to, right, we don't need the scp command because we're not actually scping any files. Okay, that all looks good. right? So we changed the names, we changed the labels, I should say, for these outputs. Now we have to change the values from which we're grabbing the IP address from, right? We no longer want it from the original Charlie. We want it from Charlie too. So let's go ahead, change that. Okay. So we make our change in our Terraform. We also go back to our workflow and we make sure we make the necessary change here as well, right? And because we're using our variables, we only have to make one change as opposed to changing it everywhere. We change it where we set that value. So I'm gonna change this to public IPB because that's what we named it in our Terraform file. I'm gonna save. I'm going to add. I'm gonna first go to the right terminal, and then I'm gonna add all of this. Add everything in this project. We then commit saying grab IP from instance 2 and we push to our latest branch. Okay. Right, we've got another run going. Hopefully this works out. If it doesn't, we'll continue to troubleshoot. But let's also go back to the rest of the successful run. And we'll just talk through it a little more, talk through what's been happening here. Okay, so we talked about this yesterday to kind of showed you what's all inside of the workflow and what's happening. We have two separate jobs. One to provision the infrastructure that we need, which is setting up the EC2 and security group and all of that stuff using Terraform. And we also set up Ansible so that we can run a playbook called setup dependencies, which itself is what actually sets up the dependencies on the server. Okay. Because everything that's happening here is being set up inside of the workspace environment. Does that make sense? Okay, I'll take that as a yes. Okay. All right. So I just expanded my Zoom view, so now I can see your thumbs ups. All right. When working with GitHub Actions, it's generally the flow. You'll be running a lot of workflows as you tweak and adjust your workflow YAMLs. You'll also have to be adjusting your Terraform and playbooks and inventories as needed. So good not to it's good to always know the context of what you're working in, right? So like an error message, for example, it's important to kind of understand where in that flow that's happening so you could troubleshoot it most efficiently. Otherwise, you'll be going around in circles, driving yourself crazy, trying to squash bugs. Okay. So this flow is pretty much good. Let's check in on the latest run, see why that failed. Okay, it looks like an error that don't quite know. I don't quite know what causes this because this is only like the third time I've seen this. And every time I've seen this, it's kind of been a fluke. Like, I don't know why it's complaining about having already imported it when it imports it every time we run. So I don't know. I'm gonna rerun this without making any actual changes because I suspect this might not be an actual issue just because I've seen it before, right? So let's let that run and let's go back to here, our last successful run, and we'll start to look through the build and deploy uh, the second job inside of our workflow. So what this does is just like the first job, it runs actions like checkout so that we have access to the files inside of the repository. And we also use Docker build X and the actions around that to make setting up our repo very easy. Because what we basically have to do is grab the contents of the repository, which right now exists on our local machine and inside of the GitHub Actions workspace. But we have to move all of those files over to the EC2, right? So we're going to use a Docker file to contain everything. And if we look at that Docker file, it's a simple Docker file. We just grab an image, an official image, in this case, Ubuntu. We run some install and update steps, the same ones that you usually and generally run at the start of a new server. We are grabbing Docker and Docker Compose. And once all of that is installed, we set a working directory. We grab the contents of everything inside the workspace and we toss it inside of the container that is to be built from this Docker file. Okay. So that is happening around here. We build and push the image to GitHub Container Registry. And again, GitHub Container Registry is just like Docker Hub. I prefer to use it just so I have less environment variables to set. I could just reuse my GitHub token and not have to add credentials for Docker Hub. Okay, so it's going to build and push the entire project. So at this point, basically the entire repository, right? Because if you look at this Docker file again, we're copying everything in the root directory, including all of its subdirectories, into the workspace directory, into app inside of the container. And then it's going to run Docker Compose up and let me actually, yeah, okay, so it's going to run Docker Compose up and here is where we would see that. Okay, loads the build context. Here's that command that we saw at the top of the Docker file. It installs all of these packages. And Oh, that's a lot. It's a lot to scroll through. Okay, there we go. And here we see it sets the working directory, copies all of the files, and it pushes to the GitHub container registry. Okay. I'm looking at this, and this isn't, I don't think this is getting run right now because all we're doing is we've written an action to build and push this. So this gets used later on, if at all. That might have just been copied over from the other Docker file. But let's continue going down these logs. So once the image has been built and pushed to the container registry, it's now it's moved from our local machine to the GitHub Actions workspace to the GitHub servers. Well, the workspace is also on GitHub servers, but now in a different GitHub server, wherever they host their containers and packages. And if we look at our counts, we could actually see that package. So this is currently there we go, where we're at. We have our Charlie project. It's been published 2 minutes ago. And this is what gets pulled down by our Ansible playbook. So if we go over to, whoops, our playbook, or playbooks plural, we've already run setup dependencies in the first job. Now we're running deploy containers. This is now installing Docker on the server itself. Okay. We installed Docker inside of the workspace so that it could package the repository and push it to the container registry. But now we have to install it on the server so that we could unpack the contents of this artifact. So we utilize our environment variables like our GitHub container registry username and token to log into the container registry and well, first we're going to ensure that this directory exists because this is where we're going to move everything inside of the container. We grab the image from the registry. When okay, we also once we've grabbed that image, we check to see if there's a running container from that image, and if there is, then we remove it, and then we create a new container. And we then copy the project files from that container to our actual server. So this temporary container is basically the step that unpacks the contents of the image. Once we've copied over those files onto the server, we can remove the container, and then we finally run that command, which I think it's it was redundant in the Docker file that I showed you. Like this doesn't need to be here. I think that was just copied over from a different Docker file because it's specified here anyway. Okay. And that's going to run the Docker Compose file at the root of the directory. Now, I said yesterday that we don't actually have our Docker Compose lesson until the next module. So we're showing it now. It's going to be optional, but highly recommended because it will definitely make your life easier. So optional for the assessment. And if we can get to a working state for our third playbook, then we'll be able to see how to do that, right? So let's go ahead and take a look at our third playbook right now because we've finished walking through our first two workflows and playbooks. We see in our latest run that both of these have succeeded. And so let's go to our third. Let's look at the playbook first. Back to our playbooks, back to our newest. Oh, why is that empty? Why is that empty? Let's see. So that would definitely explain why it failed. That is, yeah, I have no idea why that's empty. Okay. Oh, I'm on the wrong branch, of course. Okay. So our third playbook, it actually didn't fail because it was empty. It failed for another reason. Let's see if we could find why. But first, we talked about the different parts of Elk being Elasticsearch, Kibana, and Logstash. I should have said Elasticsearch, Logstash, and Kibana to follow the acronym, but you get what I'm saying. We run a lot of the same commands we ran in the previous playbook, where we're checking to see if Docker exists. And if it does, then it's just going to skip this step. We make sure it's running. If it is, it's going to skip this step. And we check for this directory, which again, it's going to skip if it exists. And here is where the naming's a little wrong. We're actually creating Docker files, right? Exactly from this YAML. Is this best practice? I don't know. It's probably not, but I'm showing it as an example of what you can do, right? So here we are setting a destination. We have three different Docker files. We're just appending, I guess, a subname or a sublabel to the end of that Docker file name for each one. We use pipe to set a multi-line command that basically creates all of these different commands and it creates them in these files that we specified. Okay, so what's happening in these Docker files? We reference the Elastic servers correctly, hopefully, and we set some environment variables. We expose some necessary ports. If we saw in our security group earlier, or if you remember, we saw in our security group earlier, we exposed 9200 for Elasticsearch, 5601 for Kibana, and it's going to point to a shared volume, and then it's going to run a command. Let's see. And I have not tested this yet. Here is another way of writing all of this out where we have the commands that we would be running inside of a terminal. We're using Docker build to create these containers. We use -f and the name of the Docker files. And they are located in the present directory, the working directory that we set earlier. And then we run them. We run each container with the necessary ports mapped and exposed. and with a lot of the same things that you saw above, right? Like the volumes that are set. So again, this is another way of doing the same thing, right? I commented that out because I wanted to try it this way, where basically we're creating a lot of what we would see inside of a Docker Compose, right? In our Docker Compose, we could specify things like a network, a volume, the images that are to be built from each Docker file. And then we have commands to run the containers from these images. So the entire assessment can be run this way if you prefer. Um, I said yesterday that we'll fit in an introduction to Docker Compose next Monday. And let's do one more comparison. So in our second playbook, we simply use a Docker Compose command. And if we look at what that Docker Compose file looks like, it's setting up each individual service. We're setting ports, we're setting volumes. We even get to set a health check, which I think, well, I don't know if it's necessarily feasible through the Docker file itself or even the bash script. And we do this for all the services that we need, right? Like the Flask API, pgadmin. This is missing. Oh, it's still missing the Nginx. I guess I never added that. Um, right. But basically, my point is what you see here in this compose is essentially the same thing that you see here in this playbook, which is essentially the same thing that you see here in this bash script. So more than one way to get this all set up. Where are we at? This failed because I couldn't find the playbook because this path is wrong. So let's go back to our workflow, make like the 50th PR. Okay, where are we? And that's our Terraform. Where we set this playbook. This is not the right path. This is not the right name. I think my directory is something like this. I can double check my previous commands. Yep, that looks right. This is fired here. Okay. Let's just quickly double check. We have infra and inventory playbooks, and that's playbooks plural with setup dash alk.yaml. We're passing in our GitHub container registry token. We should have everything set up and good to go. So let's save, check the status. Let's add this, let's commit it. Fix file paths to Ansible playbook inventory. And let's push to our latest branch. Okay, any questions on any of this so far? Right, let's see. Now, this is probably going to take a while again. So while we're waiting for that, let's go back to where we left off here. And you were trying to manually set up Elasticsearch. You were having trouble grabbing the right artifact. It was saying it wasn't available. So why is that? Okay, so let's go through our logs. Failed to fetch this artifact. Did it show us something similar above? So let's see. We ran it twice. Above, it did not fail. Down here it did. And that was after we used wget to grab this artifact. And this is the command that we got from that Medium article, right? So it's slightly different to the one inside of the README. Where is the one from the README? Oh, no, that was the one from the README then. Okay. All right. This is the one from the README. This is the one from Medium. They're very, very slightly different, just very slightly. Oh, I don't know why this one is wrapped. Try this again. Let's just try the whole thing. Let's see what happens. It's giving us that uninspected syntax. Okay. So hopefully none of that is a problem about this being configured multiple times. Okay. Let's try rerunning our sudo apt-get update now that we've gotten the wget to succeed by removing the unnecessary carrots. Oh, that's just We're seeing errors, but let's see. Oh, cool. All right. That was it. We just needed to change this command to get rid of these carrots. I'm just gonna make that change now. Changes. Oh, it failed again. Why did it fail this time? Am I looking at the right one? Still can't find it. Wondering if it can't find it because I didn't set the working directory. So I'm going to compare this third playbook, sorry, this third workflow. Yep, that's exactly what I was missing. Forgot to set my working directory. So let's add that wherever it needs to be added. Okay. And the fourth time is a charm. They are for the third. All right, we'll see. We'll see. We'll see where that goes. Okay. So we are parallel tasking between these two different ways of setting up Elasticsearch, but we're slowly making progress. Which direction? So I'm gonna run the second. Shoot, I don't want that. That's the wrong terminal. I'm gonna go back to the right terminal, and I'm gonna run the second command. We're gonna start Elasticsearch now that we've installed it. Hopefully, it's not just gonna hang there. And then we can finally test our connectivity using curl. While that is, oh, cool. Let's see. Oh, okay. So running a status, we see that it's loaded, it's active, it's currently running. Disabled means it's not going to run by default whenever we start or restart the server. So we could run enable to ensure that it does. And let's rerun our status. We can now see that it's set to enabled and it is still running. Okay. Now if we run this curl command, we get a response. It looks like the response is giving us a name based on our IP. We have a cluster name called Elasticsearch and a UUID. Okay. Cool. So we've set it up manually on our EC2, on one of our EC2s. And it's not really it. Let me see. Yeah, I don't see anything else in the demo. So let's see, what can we do with Elasticsearch? Also look at, oh shoot, it failed already. Okay, this one timed out. How did this one time out? This one timed out, but the previous runs did not. Let's look at what's happening here. Okay, this is happening at setup elk dependencies. So that is happening in our playbook. Name of the entire thing. It didn't even reach the first task. Oh, let's see. A few things to check. Where we are specifying these playbook runs inside of our workflow. Let's make sure everything we need is provided. So we need our token. That wouldn't be the cause of the SSH failure, though. We also, no, actually we want that. Okay, so again, each job is its own individual environment. So that's why I have the writing of the SSH key in multiple places, right? So yeah, I do have that here. Okay. So that is here. SSH key is in place. Okay, these environment variables that are set above the job level mean they are available to all of the jobs. So this is not the problem. Doesn't even get to this point. Oh, okay, right. This is the second workflow. Or the second workflow, this succeeded, whereas the third one failed. So I'm checking out my code. I write the SSH key and I set up Docker build. Down here, similar, I check out the code. I might just run this debug statement. I write my SSH key from my secret. We could use things like an if condition with a false value to basically disable the job. That's why if we look here, we'll see that install Ansible on runner was skipped. So this didn't run, and we set our working directory. Was there anything else that we missed? Oh, okay. All right. So I mentioned this yesterday very briefly. You have, and we talked about it before during the last module. You have multiple ways of doing things in Ansible, right? Ansible is like super flexible, right? So you could write your inventory files as INI files, which are very simple configuration files that look like this. And we have a hard-coded IP address here. Or you could use a more dynamic YAML syntax, which allows us to more dynamically set details like the Ansible host. So our YAML pulls the EC2 IP address from the environment variables, whereas the INI file does not. And so that's why it failed to connect this time around. We just need to change this file type to YAML. So let's also just double check everything else. Extra variables are getting passed in. That's the GitHub container registry token. Switch to this. Let's commit, uh, use YAML inventory instead of INI. And let's try it again. While that's happening, let's look at today's challenge. I don't think I like this challenge. Um, what is this? Yeah, this is a lot. And this asks you to put yourself into teams, deploy the infrastructure that you made from assessment two, set up CloudWatch monitoring. I mean, it's optional. I guess if you want to work in teams, you can. But basically, use the exact same setup you did for your assessments, and we're going to add some CloudWatch monitoring. You're going to monitor for two metrics on each service, similar to how we did yesterday. And then you'll set up a dashboard, similar how you did last week, to monitor everything. And I would want to add to this basically, you've already everyone here passed assessment two. So you've already gone through the process of setting up your infrastructure using Terraform and Ansible, with the Terraform and Ansible commands being manually run. Now try doing that with GitHub Actions thrown into the mix. So just like we've been seeing today, running your Terraform and Ansible from a new GitHub Actions workflow. Okay. And we'll see if we can get this to run by the end of the night. Because once it does, then we can look at the three different containers for the Elk stack, one running Elasticsearch, one running Logstash, and one running Kibana. Okay. Feel like I'm losing my voice. We've been here for a while, so I'm gonna cut the recording here. I'm gonna open up breakout rooms and let's meet back at 9. Sound good? Okay. Okay. Stop sharing.